Hello, our lesson for today is about the serial in parallel out register or SIPO. Here is our simulation design circuit for implementing the serial in to parallel out transfer of binary data. The circuit is comprised mainly of 4 D flip-flops with preset and clear inputs that are activated by logic 0. Let me repeat the operation of serial loading of data inputs as in our previous lesson in SISO. Serial data bits are loaded at the D input of the first flip-flop. At the arrival of the clock signal, the first data bit is loaded to the Q output of our first flip-flop 1. The next data bit is loaded to the first flip-flop only upon the arrival of the second trigger pulse from the clock 1 source. The next flip-flop 2, gets its input from the output of the first flip-flop 1, so whatever output of flip-flop 1 is will be transferred to flip-flop 2 at the next clock signal. The same condition will happen to flip-flop 3 and flip-flop 4, since the output of the previous flip-flop becomes the input of the next one. Notice that the D inputs of each flip-flop is connected to the Q output of the previous flip-flop except the first D flip-flop, where its D input is connected to the data source through SW1. During the arrival of the succeeding clock signals, data is shifted to the right one at a time. That means the output of the next flip-flop will be the output from the previous one. At this point, let us now simulate this operation. Initialize the outputs by making sure all flip-flops are cleared, and this can be done by switching SW3 to ground or down position and then switching it back to up position. Notice no LED is lighted at this time to indicate all 4 flip-flops are cleared. Let us assume that our 4-bit serial data is 0101 and is inputted from right to left, 1 being the first data bit. Let us set SW1 to up position. In this simulation diagram, the outputs of 4 flip-flops are being monitored at the Q outputs of each flip-flop and are represented by the red color for logic 1 and blue color for logic 0. To load the data to our first D flip-flop, we will now press SW2 once. Notice the Q output of flip-flop 1 having a red color to indicate logic 1. For the next input, let us position the switch SW1 to down position corresponding to a 0 value. Let us press the clock switch SW2 to load this value to the first flip-flop. Notice that the Q of flip-flop 1 now is color blue, meaning 0, and Q of flip-flop 2 is red, meaning logic level 1. Flip-flop 2 output is high because its D input is previously the output of flip-flop 1, which is 1. For the next data input 1, we set SW1 to up position, then press and release SW2 once. If you will notice, all the output states of the flip-flops are shifted to the right one at a time as SW2 is activated. For the last input of 0, place SW1 to down position and apply clock signal by pressing SW2. Notice the color at the Q output of each flip-flop. Flip-flop 4 is red, flip-flop 3 is blue, flip-flop 2 is red, and flip-flop 1 is blue to indicate 01, 01. Condition: read from left to right. If we continue to apply clock signal with SW1 down in down position, there will come a time where all output levels of 4 flip-flops become 0 or color blue. By permanently positioning the switch SW1 to up position and continuously triggering the clock inputs, you will notice that after 4 clock transitions from 0 to 1, all 4 flip-flops will have high logic levels or red colors for their Q outputs. To get the parallel output or the simultaneous retrieval of outputs from the 4 flip-flops, we need to permanently press switch SW4 here. The 4 outputs are connected to 4 AND gates U6A, U6B, U6C, and U6D, respectively. But all the other terminals of the 2 input AND gates are connected to a common terminal VCC via switch SW4. When SW4 is pressed, the outputs of the 4 AND gates follow the outputs of the 4 flip-flops. These are monitored by LEDs D1, D2, D3, and D4. In our example, D1 is off, D2 is on, D3 is off, and D4 is on. In summary, serial in, parallel out register operates by transferring data from the data source one at a time and then retrieving this serial data at the output terminals in parallel mode by activating SW4 that acts as a second clock signal source. That ends my presentation. Thank you very much.